And let's move on to the next thing. So this is this is pretty powerful what we've got right here. So in a few lines of code, we've got this is our index, which is 18 lines. We're requiring Express. We have our body parser. We're pulling in Mongoose. We're defining some things to use within our app. We're defining our cat routes and we're serving it up. We look at our cat model and we look at our cat routes, and we've got that's pretty simple to be doing some pretty basic stuff. So I could build an application just with this.
Right.
A very simple application that keeps track of cats and maybe add some validation. But Node itself is really geared towards being a middleman. So I like to think of Node as like an air traffic controller, right? If you're flying in the air traffic controller, you want to tell him who you are, what you're planning, and keep it quick and simple. If you're sitting there telling your life story, he's going to listen to you, and then the plane's going to crash into the tower.
Yeah, I mean, when I'm just outside looking in, some feedback on the app I see so far, I see three main concerns this app is doing. Yep. Right now, we've got an app that itself is serving a server. It's creating a server.
Yep. It's
processing requests, which is different than having a server. It's something a server does, but it's a very specific need, and it's also doing a lot of data interactions.
Yes.
So is it good to do all those things in the same place, or?
It depends. So what I was kind of alluding to is that you'd really want to have some back-end services that do the real number crunching and the data processing.
Why?
So Node itself is a single event loop. And so Google V8, which Node runs on top, is threaded. So you can have threaded processes, you can do exec, you can spawn processes, but Node itself has a single event loop. So that means it just keeps spinning through and it says, hey, what am I doing, what am I doing, what am I doing, gets to the end. If you're coming through in that event loop and you start doing some really heavy processing here, let's say I had 10,000 cats, right, and I wanted to then take those cats and I want to arrange them alphabetically by like maybe 20 parameters deep, like sorting them.
So what you're saying is that, if I hear you right, with the single event loop, that's why we have callbacks everywhere, right?
Correct.
So go figure this out. When you're ready, I'll catch you on the next iteration of the loop.
Yep.
But if I stop and I pause and I make you process all that data, then we're slowing down everybody else.
Yes.
Okay, so how do we fix that?
So the way that this should be architected, and especially in a lot of businesses now, is you already have some back-end services that do a lot of different things.
Right, maybe .NET, Java, whatever.
Yeah, and I've got a new client application that needs some data, but it could be a mobile app or whatever, and I don't need to be sending all of this data, and I don't want to hit all these different endpoints. So where Node really shines is putting it in between, right as a web API, right at the edge of your network. So all these databases that already exist and all of these services that already exist, I can go and aggregate and orchestrate and then send back just what I need for my client.
So that's pretty cool, because a lot of places, I've done a lot of consulting in my career. I know you have too.
Yeah.
They already have a lot of applications in the back end. Let's say it's all .NET. They've got stuff they've written for years. And usually when an app or a project comes up, developers have said, hey, go add a new UI to this, or go add this new feature. But you can't change the back end systems.
Not easily.
So this would allow you to say, look, financially, we can't change everything. Yep. Leave the back-end systems there, and if I hear you right, you're going to put Node in front of those. Yep. So it's not doing the heavy number crunching, it's deferring that to the other places, and then Node acts as like a aggregator?
Orchestrator, those are the architectural terms. I like to think of it as an air traffic controller.
Air traffic controller. So it's between your .NET and your glass, your screens.
Yeah.
Okay.
I don't need to send back this 10,000 JSON document that I got from my service to my web application, right? And I don't want to change the service to trim and get the specific data I need. Right. But I can use this in between to get from service A, B, and C and just send down what I need.
Why not just go right to .NET in this case? Why Node?
Just Node, first of all, is written in JavaScript. So it's very easy for people who are working in the front end to become accustomed to it and to write with it. And it's simple. I mean, look at how quick we wrote this. I defer to you because you have a lot of .NET experience. I don't have a whole lot of .NET experience, but...
Well, I mean, yeah, I could easily go back and say, well, I know .NET very well. I could write a web API very quickly. But it sounds like, in my experience, this has been true, and tell me, because you have more than I have, when I create a Node server, that it's really, because of that event loop and all that, it's really built for that fast I/O.
Yeah.
I mean, faster than, like, if I crank something up with Java or .NET, I'm going to have to deal with even more server stuff going on. And it seems to be a little more bulky.
Larger
it does
memory
more.
Footprint, yeah, larger memory
But
footprint.
Node seems to be like, I need to get fast I/O, boom, 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 I can run through it.
That's exactly, yeah.
Okay, so basically Node is that great middle layer air traffic controller, you call it?
Air traffic controller.
And then we use our backend. Okay, so we'll agree there. .NET in the back end, Node in the middle.
Well, I would say Go in the back end, but you know me.
Go. That'll be the next one.
That'll be the next one.